So now we're going to get into the derivative as a function, okay? And how is it that we find the derivative of a function, all right? So what we're going to do is we're going to define, right? We had the limit, their derivative was equal to the limit as x approaches a of f of x minus f of a over x minus a, okay? It was also equal to, all right, the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, and so like we were looking at the derivative at points at a particular point. And so now what we're going to do is we're going to ask ourselves, well, what if I wanted to generalize, right? I wanted to talk about the derivative of a function, its rate of change anywhere on the function, right? So what if I wanted to find the rate of change of a function anywhere on the function? Function anywhere on the function. Okay? So what we're going to do then is we're actually going to utilize something that very much looks like this, right? It looks like this guy in order to do that. We're going to say that the derivative of the function is the limit as h approaches 0 of f of x plus h minus f of x divided by h, where x, right, belongs to the real numbers, right? Some kind of real number. But it's a variable. Okay, now it's going to be a variable. So we're going to find the derivative for any x here. Okay, any x at all. All right, so here's our definition of the derivative. And let's take a look at an example and we'll actually go find the derivative of this function. Of f of x equals root x. Okay, so what that is, f prime of x is going to equal the limit as h approaches 0 of the square root of x plus h minus the square root of x, all divided by h. Now, since we've done a ton of work with limits, what we know we can do here is we're going to multiply the top and the bottom by the conjugate. So this is going to be the square root of x plus h plus x, square root of x, divided by the square root of x plus h plus the square root of x. And so this will then equal the limit as h approaches 0 of, and so we've got a difference of squares here, so it's going to be the square root of x plus h squared minus the square root of x squared, okay, divided by h times the square root of x plus h plus the square root of x. Now, here's the deal. Remember before when we were doing derivatives at a particular point, we wanted to make sure that we got rid of the h's on the bottom. We still want to do the same thing. We want that exact thing to happen, okay? So what we're going to do here is we're going to simplify, and hopefully what's going to happen is that our h's are going to disappear. If they don't, not differentiable. So we got the limit as h approaches 0 of, this is now going to be x plus h minus x divided by h times the square root of x plus h plus root x. And so that's going to then equal the limit as h approaches 0. And so that's just going to be h over h times the square root of x plus h plus root x. Yay! Okay, good news, right? That those h's are going to cancel. That's going to become a 1. And so this is now the limit as h approaches 0 of 1 over the square root of x plus h plus root x. Okay? Cool. Now, here's the deal. Since this is a rational function, right? This whole thing, that's a rational function, and h is in the domain, or 0 is in the domain of that rational function. It's not going to cause us to divide by 0, so we can actually just substitute. So now this is going to equal 1 over root x plus root x, which equals 1 over 2 root x. Yay! Which, by the way, if I rewrite this using the power rules, this is 1/2 x to the negative 1/2. We're going to see that notation a lot more, right? It ends up being a lot more handy for calculus than utilizing the square roots. Okay? Now, finding our function. What did we do? Right? We found the derivative, we utilized that derivative equation, okay? And as we were going through and using that derivative equation, the difference here is that we had a variable. We were actually solving for some kind of function. We've done this before, right? You know, you've solved for functions in the past. The difference, though, is that we're not actually getting a number. We're not getting a number like we got a limit. Instead, we're getting a function out. Okay? Excuse me. Actually, I guess you haven't done this before. So this is the first time. What you're going to get here is you're going to get a function as your response, right? So this thing here, 1/2 x to the negative 1/2 and 1 over 2 root x, they are the derivative for anywhere on the function square root of x, okay? So all I need to do here is I just need to actually just plug in a value for x, and that will give me the derivative at that particular point. So for example, what is the derivative of square root of x at, let's say, 4, 2. Okay, so there's a 0.42. All I need to do now is I notice that f prime of x is going to equal 1 over 2 root x. Okay, and so I'm just going to say then that f prime of 4, it's a function, so it's going to be 1 over 2 times the square root of 4. So that equals 1 over 2 times 2, which equals 1/4. So that is, in fact, the derivative, 1/4. Really handy, right? I could say, you know, how about 6? Or x equals 6. Another way to see that? Well, f prime of 6 is then going to equal 1 over 2 times the square root of 6. And so that's 1 over 2 root 6. We'll just leave it at that. All right? And that's actually the instantaneous rate of change, right, for that function at the point 6 root 6. Okay? Just like 1/4 is the rate of change for the function at the point 4, 2. That's also the slope of the tangent line, right? Derivative, slope of the tangent line, same thing, okay? So consequently, one of the ways that we can actually find the slope of the tangent line is to find the derivative for the function and then plug in the point where the tangent line is. Okay, that's another option that we have. All right, let's take a look at another example. All right, so now try and see if you can follow along with me. Okay, we want to find f prime if f of x equals 1 minus x over 2 plus x. So the first thing we want to do is we want to actually put this into our derivative equation. So f prime is going to equal, 1 minus x plus h over 2 plus x plus h, right? That's your f of x plus h, divided by, or excuse me, minus 1 minus x over 2 plus x. And then we're going to divide that by h. And we're going to find the limit as h approaches 0. Okay, we'll change this to f prime of x. Not quite ready for just f. So we got the limit as h approaches 0 of 1 minus x plus h over 2 plus x plus h minus 1 minus x over 2 plus x. Okay, so what this is that this is a rational equation, or it's a rational function, all right? And we're dividing two rational functions, basically. So if you remember what we've got to do there, what we've got to do is we've actually got to find a common denominator, okay, and combine the terms on the top so that then we can divide by h, okay? So what that means is that the least common factor for 2 plus x plus h and 2 plus x is is 2 plus x plus h times 2 plus x. So we'll multiply the top and the bottom by both of those. So we're going to get then 1 minus x minus h. Okay. That's the top part there times 2 plus x minus 1 minus x times 2 plus x plus h divided by 2 plus x plus h times 2 plus x. And we're going to find the limit as h approaches 0 of that value. Okay, all divided by h. Okay, so hopefully the thing on top is actually going to end up, we're going to cancel out the h's there somehow. We go. So now I'm going to have to scroll up a little bit. Okay, this is going to equal the limit as h approaches 0 of, and now let's do some multiplication here. So this is going to be 2 minus 2x minus 2h plus x minus x squared minus 2h, or minus hx, minus, and now we're going to do this part right here, okay, minus, and I put it in parentheses because like I have to keep my positives and negatives straight. So there's 2 plus x plus h minus 2x minus x squared minus xh. All then divided by 2 plus x plus h times 2 plus x, all divided by h. Now you notice that the denominator here on the top fraction, I didn't actually, I didn't simplify it yet. And the reason why is because I'm not going to factor out the h's there. In fact, if you look at it, if I just plug in h equals 0 into that, that's no problem. It's just going to be 2 plus x squared. That's okay. That's going to be just fine for me, okay? So what I want to do now, though, is I want to go in and I want to be like, okay, so I now need to simplify this. I'm going to hope that everything that doesn't have an h goes away, okay? So this is then going to equal the limit as h approaches 0 of, okay, 2, and you'll see I've got the minus 2, so that's going to go away, right? The minus 2x, oh, excuse me. I've got a minus x squared here and then a minus minus x squared here, so that the x squareds are going to go away, okay? Then I have an x here and a minus x here because I've got to factor in the negative x, so the x's are, again, going to cancel out, okay? And then I've got a minus 2x and I've got a plus 2x here, so the 2x's are going to go away too. Whew. That's good news, okay? So let's just write out what we have remaining. I've got negative 2h minus hx, right? And then I have a minus h, and then I have a plus xh. Okay, if you could take a look at, remember the negative here. You got the negative xh, you've got a negative h right there. Okay, everything else is gone. And then we're going to divide that through by 2 plus x plus h times 2 plus x divided by h. Now, if you remember, this is a fraction, so what we're basically doing is we're going to say, okay, this is going to then equal the limit as h approaches 0 of, and again, just combine some like terms, it's going to be negative 3h, right? Okay, negative 3h divided by 2 plus x plus h times 2 plus x, and then times 1 over h. And so this will then equal, okay, the h's will cancel out, and we're left with the limit as h approaches 0 of negative 3 over 2 plus x plus h times 2 plus x. Now again, Since h is in the domain of this rational function, we can just substitute. So this is then going to equal negative 3 over 2 plus x times 2 plus x, because the h is equal to 0, or negative 3 over 2 plus x squared. All right, this is going to take some practice. Okay, it's practice, 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 because there is a lot of algebra involved inside of finding the derivative of functions using the change functions. Okay, the rate of change function or the difference quotient. All right, so make sure that you get in and you do the practice. Right, you want to make sure you get in, you do the practice, you do the algebra, because it's gonna help you out a lot. Right, in the coming weeks and months, or however long we're going to be together. Okay, so that's the derivative, right? You've seen the equation before. You know the equation because you're going to have memorized the equation. Then you just need to kind of basically plug the function in, right? It's kind of composition. It's some composition work, okay? And then it's simplification and finally finding the limit. All right, that is finding the derivative of a function. I hope you feel like empowered, like you really know your